Okay, so the first thing we got is 2.121. Now, when I pull up a homework question, you'll know that 2.121, that's in the book. So if you go to the 2.1 homework in the book and go to number 21, this is going to be a similar problem to number 21. But if you print out your homework online, or if you go back to your homework online, it looks like number 5 online. So it's 21 in the book and number 5 online. And it says domain, looks like domain and functions increasing and decreasing. So we're going to, all right, so take a look at this one. And it's asking you some questions about this function. Okay, now, first of all, domain and range. Domain is from negative infinity to negative 2 on this function right here. Negative infinity, because that little arrow right there is called negative infinity. Hold on, I'll show you what I'm talking about. I can't do this on the This is called negative infinity right here. And it's not going to write it. That arrowhead right there is called negative infinity. This arrowhead is called positive infinity. This arrowhead right here is called negative infinity. And this arrowhead up here is called positive infinity. So, this function has an arrowhead on it, so that means that the domain is from negative infinity to 2. Now, the reason you get parentheses on both of those is because infinity is never inclusive. If you can tell me what infinity is, I'll tell you it's inclusive. And 2, it does stop at 2, and you could put a bracket there because on this function it stops at 2. But on this function it doesn't start at 2, it starts at 1.9. So that one's not inclusive. Negative 2 to what? To 4. And that's not inclusive because it's got open circles. And then bracket 4 to what? Infinity. So that should be your domain for this graph. I don't know what they're asking. We'll look at it in a minute. I think it's doing it by parts, is it not? Yeah. Okay. So that's how you do the domain for that function. The range for this function, this domain. The range for the function, well, it starts at negative 2 because you're looking at the y-axis, and now it crosses, it's inclusive of negative 2 because it crosses negative 2. See there? Crosses it right there. And it goes, well, it doesn't go anywhere. Does negative 2 go anywhere? No, it doesn't. But this one catches it right here because it's going down here. So this right here is included in the range for the whole function. This is a piecewise function, so I don't know if that's what they're wanting. Okay, do they ask for the range on it? Because the range for this function is negative 2. That's it. For this function, it's negative infinity to, what is that, 0.5? And that's inclusive. And then from, is that 1 to infinity, that's your range. Okay? It's a problem that I would not pick for the domain and range. If I was to give you a test problem, I would not give you a problem like this on domain and range. Because it's a piecewise function, it's broken up, and it's kind of a tricky problem. All right? Now, the function is see, it's decreasing, then it's constant, then it's decreasing. So most of it is decreasing. Now, how do you know decreasing and increasing? Well, let me draw a plane first. Now, let me also show you one more thing. Domain is what values? Range is what?
1.
Increasing and decreasing is x values. So what is the only one that isn't x values? Range. So you need to write that down, because when we do increasing and decreasing, y'all are going to try to put it in terms of y, and it's not. Okay? The y is the elevation. Now, if any of you know anything about planes, there's 3 dimensions to a plane. There's this way, and then there's this way. So it has 3 dimensions. So, but they only want to know one, and that's if it's increasing or decreasing. So I'm going to take my handy dandy line maker. Okay, there's my plane. All right. Now, I'm going to take that plane. Now I'm going to change that. There. I'm going to take that plane, and we're going to put it over here. Now I'm coming from which way do we read? Left to right. So your plane's always going to be coming from the left, unless you're from the Middle East, Masalama. Okay? If you're not from the Middle East, then most of you will come from left to right. So what's this plane doing from left to right down this function? It's descending. So it's decreasing from negative infinity to 2, negative 2. And then it kind of bottoms out. And what's it doing from negative 2 to 4? It's, I guess you call it, what's it, taxiing on the fairway? In other words, is it going up or down? It's not doing anything. What's it doing? It's staying constant. And then on this function, it's going from what? It's decreasing from, what is that, 4 to what? Infinity. So decreasing from negative infinity to negative 2, constant from negative 2 to 4, and decreasing from 4 to what? Infinity. Huh? Yeah. Going down, yeah. You went under the ocean for a while, okay? Yes.
I guess for me that's confusing because your x values are increasing.
Yeah, you don't do that. What you're doing is, what are the y values doing?
Okay.
That's what that's what I don't say that, I just say elevation. What's happening? Decreasing. Boom. The y values are decreasing as x goes from left to right, then it's constant left to right, and then decreasing from left to right. So my increasing values, and I don't know what it's asking for here, the domain of the function, well, here we got that right. The function is constant at negative 2 to 4, and we said that, negative 2 to 4 is constant. And the domain of the function, if they want the domain of the whole function, that's going to be kind of tricky. But it looks like to me the domain is all real numbers, because this cancels this out, and that solid one cancels this out. Negative infinity to what? Positive infinity looks like to me, I'm just going to put 3, because I don't want to have to type in all that. So that would be all real numbers to me. Negative infinity to positive infinity. Yep. The range of the function, this one, I would say negative infinity to, negative infinity to positive infinity, because even though this is halfway through, you've got this arrow right here, and you've got this arrow right here, and no, they don't line up right here. So the negative infinity to negative to 0.5, and then from 1 to infinity. That would be your range. negative infinity to 0.5, and then 1 to positive infinity. There it is. Negative infinity to 0.5, and then 1 to infinity. Now the U right there, that's union. That means that what's make up both fields. So if there was an intersection, it would be an upside down U. Intersection is something that overlaps. Just remember intersection of a highway. One asphalt overlaps the other. Okay, so intersection means overlap. If there's an overlap.
So you use the union
when you have two separate sets.
Oh, okay.
And there's a set here, and then there's a set here. Now, why didn't I include anything having to do with this? Because this is right in here on this function, so this is actually taken care of right here. So you don't have to worry about this. The only part you have to worry about is the break between 0.5 and what? 1. You need to blow it up. Right here. There's 0.5 and there's 1. So there's a break where it's not continuous between 0.5 and 1. Okay? Now, if this had been a line going from here, like from here up to here, like to there, then it would be negative infinity, positive infinity. But since it's discontinuous and you have no, just think of it like skating, right? You're skating on a piece of concrete. You got a skateboard or skates, and you're skating on concrete, and you hit the grass. What happens?
Stop.
You fall down. You stop. Why? Because skates and skateboards are not designed to go on the grass. So here we go. Skateboard. Boom. Why do I hit grass? Because there's no concrete here to go from here to here. Think of it as concrete in skating. I go here, boom. The reason it stops is because now, if this was 1 up, if this was right here at 1, then yes, it would be the same because it would be fluid. But since there's a break between 0.5 and 1, that's grass. Okay? What else does it ask? Is that it? I don't like that question because it's confusing.
Yeah, it's very confusing.
So let's do another question. I'll tell you if it's a better test question or not. Let's see, read page. Let's go. That was 21. Let's go with the next number, which is 43. 43/11. That's a good test question, but that's not what they're asking. They're not asking if it's domain or range. They're just asking if it's the negative function. So let's talk about it. Complete the left half of the graph. This is y is equal to f of x in the figure for each of the following sections. F of negative x is equal to f of x. So f of negative x, what does f of negative x look like? Well, if you plug in the points, let's plug in the points. Let's just do this elementary way. X and y. Sorry. All right, so 0. I plug in 0 for f of x and I get what? 0. This point right here, x is 1, negative 1. And this point is 1, 2, 3, 4, and 5. Everybody get that? That's f of x. F of negative x means that wherever there's an x, I'm going to plug in x, but I'm going to plug in what? Negative, the negative. Well, there's no such thing as negative 0, so That stays the same. -1, -1, -4, and positive what? Okay, what this means, if you see f of -x, that means that wherever there's an x, you put a negative in front of it. This, you don't have anything in front of it, so you just 0, 1, and 4. So let's plot these points. 0, 0 is right there. -1, -1 is right there. And of course, -4, +5. So we got a W. Dang old C. And we can find the mouse there. And we feel good about ourselves. Now you do this one. Do a chart. Now you know what negative f of x looks like, or f of negative x looks like. F of negative x looks like this, right? I'll do it in red, so that way you'll know that that's the negative. F of negative x looks like that. So here's the red part right here. Now what's going to happen when you do this? Well, what is f of x? It's another way of writing what? Y, Hubert. Yes. So if negative f of x, you might as well say that's negative what? Negative y. So change these guys to what? Now plot those points. 0, 0. Boom, boom. Let's do it in blue. So blue, there's black. I'll do it in black. Since that's blue. And then -1, +1. -1, +1. -4, -5. So if I want to compare the red and the black line, which I can't do because the mouse is not cooperating, it's going to look like that. So which one is that? I don't see one. I must have done something wrong. Unless they're comparing it, it's this one. Okay, they're comparing it to the blue line. I'm sorry. I thought they were comparing it to the red line. So where's my... And that is this one right here. Test question, maybe. Doesn't really... What they're trying to get you to do is understand what's symmetrical around the y-axis and what's symmetrical around the origin. Now this is very important in calculus. Very important. Because the first section of calculus is on odd and even, sine being odd and cosine being even. Because cosine is symmetrical around the y-axis and sine is symmetrical around the origin. So if it's symmetrical around the origin, it's odd. If it's symmetrical around the y-axis, it's even. And we'll get into that today, doing that. That's not a big deal. But that's how you do it. It's just a manipulation of numbers. Here's f of x. What would f of negative x look like? And that's this right here. Well, then what would negative f of x look like? Negative f of x would look like the black line. F of negative x would look like the red line. Okay. That will come. Don't worry, it will come after we do 3 or 4 problems. 2.1, 47. 47/12. So I am doing your homework for you. Each one right after the other. Based on the ordered pair seen in the table, make a conjecture about whether the function f is even, odd, or neither. Well, just plot it. That's what I would do. I mean, why would they give you a bunch of points if you're not going to plot it? To me, I would plot it. So you got a halfway decent graph here. That's very halfway decent. Negative 3, positive 10. Negative 3, positive 10. No coughing. Negative 2, positive 5. Negative 1, positive 3. That's like a parabola. 1, 0, 0. 1 and 3. 2 and 5. And 3 and 10. Yep, it's a parabola. Okay, you get the point. All right, the function is symmetrical around the y-axis. Why is it symmetrical around the y-axis? Because if it was symmetrical around the origin, it would look like this. Okay? So remember that. Symmetrical around the origin means like that. Symmetrical around the y-axis means this side looks just like this side. So y-axis, so that means it would be even. And we're going to talk about that today. Really, operator error. It's even because f of negative x, I don't know what they're asking there. Okay, I got to show you that. But when f of negative x is equal to f of x, that is an even function. F of negative x is equal to f of x. See? F of negative x is equal to f of x. F of negative x is equal to f of x. Okay? And you feel good about yourself. Right? I don't hear too many comments. I'm starting to worry about y'all. Y'all are going to end up living in a ditch for long. B, what do you call it? Starts with an O. Optimistic. Let's be optimistic. Y'all talk. God. There we go. Determine whether the graph of the given function is symmetric with respect to the x-axis, symmetric with respect to the origin, or neither. Use your calculator. Should you use your calculator? Duh, yeah. Unless you want to do 2 to the 5th power, which would be 32, and 2 to the 7th power, which would be 128. Yeah, use your calculator. Yeah. So let's pull it up. Let's pull up our handy dandy calculator. And when we pull up our handy dandy calculator, 3 or 4 days later, we're going to get graph y is equal to x to the 7th minus 5x to the 5th. Now I will tell you that the leading coefficient is odd, so it's going to look like our cubic function. So chances are it's going to be symmetrical around the origin because the cubic function is symmetrical around the origin. How do you know that? You know your parent graphs. Remember me telling you the exponent is odd, it's going to look like the x cubed function, only the bottom is going to bottom out a little bit more. This one may look like a saddle. In other words, you may have an extreme going up and then come down, and there'll be an extreme minimum and then go back up. But it's going to look probably like a saddle. So that means it's going to be probably symmetric around the y-axis. Maybe. I don't know. Graph. And you wait. And you wait. Now, you have no idea what it looks like. So what I usually do here is go to Zoom. And then I go to Box. It's kind of like Zoom Window and CAD. You know how you zoom window? Same thing. So zoom and put your left box, left right here, enter. Because all you need to see is around the y-axis and the origin. And enter. There you go. There, you see that? You see that function right there, that cubic function? There it is. So it's symmetrical around the what? The origin, Hubert. That's right, class. So I would
answer,
say,
but I don't know.
respect to the y-axis. Huh?
I said I would answer, but I don't
Okay,
know.
that's fine. So, let's talk about odd or even. Let me find the section in your book so you can look it up for those 2 or 3 people that actually use the book. Let's find do homework. I don't want to do homework. I want to go to chapter contents. What section were those questions out of?
That was 2-1.
2-1. So let me go to chapter 2-1 ebook. And the reason I want to pull this out for you is from the book, is because some of you don't have the book and all that.
There's a book on there, right?
Really? Why is it doing this? I bet I know. I'm not on Firefox. Hold on right quick. Let me pull it up to Firefox. I'm supposed to have a fit, ain't I? I forgot to have a fit. Email my math instructor.
So the little deal with signing in through Blackboard, you might have plus with that error moved here. I mean, they're just letting that roll like that. I mean, what happened from every other semester that it worked fine, that all of a sudden it's like,
I
got
think
these special instructions.
Well, I'm going to be honest with you. We've had a problem ever since they've gone through Blackboard. It used to be the first couple of semesters you go to tctc.mylabsplus.com
Yeah.
and everything worked fine.
Okay.
But then some bright person said, "Oh, let's make it go through Blackboard. Why? That way you can substantiate my job. I keep Blackboard running, and that way more people on Blackboard. That way I keep my job." So they forced it through Blackboard, and it caused all kinds of problems because Blackboard never is up, and then it just caused problems. So that's all I can tell you. 2.1. Okay, something's wrong. Remove clutter so you can focus exactly on what you want to read. What? What clutter? Something's wrong. Okay. Well, there's more than one way to skin a cat. I'm going to try one more thing. This is the way we used to do things. You remember this?
Mm-hmm.
Now if I can, what the? Okay, can you let me sign in now? There. Now if I can remember. This is right. I made a class yesterday because I couldn't get into the, okay, I don't know what this is. Go away. Go away. I made a class up yesterday so I could go through and do homework. So that's what we're doing. You're not going to see this, but anyway. 2.1. See, of course, compass works fine. Okay, it don't. It was working yesterday, so okay, I'll write it on the board. I don't know. I guess they're just having
Are they gonna
problems.
reimburse all these people for paying this money and it not working?
I don't know. I don't know what they're gonna do, but I've never seen it this bad.
I'm gonna guess.
I don't know. I just really am very, very amazed. or disappointed because I've never seen it like this before. I was going to get back to one of your questions. Okay, there's the two formulas right there. So write those formulas down. If f of negative x is equal to f of x, then your function is even. So f of x is equal to f of negative x. Your function is even. That means that it's symmetrical around the y-axis. And that's true, because if you think about it, look at a parabola. Okay, let's say that this point is 1 and 1. That point right there is 1 and 1. Your x is 1, your y is 1. But over here, x is what? Negative 1, and y is 1. So, how would you write this? This is f of negative x, and this is f of x. Okay, or this is negative x, and this is f of x. This is positive x and f of x. F of x is what? The same. What's the only thing that's different? Is the x. The x is different, right? One's positive and one's negative. Positive and what? Negative. The x input here is negative. The x input here is positive. So that's why we get symmetric around the what? The y-axis. So hopefully you see that. Now, what if you have this? F of negative x is equal to negative f of x. If you have this, which you've already done this, you did this with the previous test right here. So you don't have to do much work. And then you just put a negative in front of the function. If you have this, then you have an odd function, which means that it's symmetrical around the what? Remember, O and O. If it's odd, it's symmetrical around the origin. So let's take a look at something simple, like x squared. We know that x squared is a parent graph, right? Yes, Hubert, we know that. Thank you, class, for the interaction. It's always nice to have interaction. It makes class more comfortable and makes it go much faster. Or I could just do like provided and just not have interaction. Maybe I should just do that. So I don't know talk about math 200% of the time. All like that. F of x is equal to x squared. So let's put it through the test. F of x is equal to f of negative x. Oops. F of negative x. So if I plug in a negative x in for x, and I square it, what am I going to get? I'm going to get x squared. Okay? And x squared is equal to x squared. So in this case, I get an even function. And that means that it is symmetrical around the y-axis. A lot of people say, well, Hubert, that's the origin. Yes, but if it was symmetrical around the origin, each point here would be reflected where? Each point here, which is x cubed. All right, now, since I found that it's not, since it's even, do I need to go test it to see if it's odd? No, it's either going to be even, odd, or none of the above.
So
The
that
reason I put none of the above is I always have problems spelling IE words. And I know I before E except after, and I never do that, so I don't know how to spell them either. It's either NIETHER or NEITHER, one of the two. So, yes, sir.
So would that be true even if it had a horizontal shift, it would still be true?
Oh, yeah.
So
Doesn't matter.
that one going around the origin kind of just makes it a little confusing because
Yes.
it goes around it.
Yes.
Okay.
Okay. Now you try. We'll do x cubed minus 1. Try that one. X cubed minus 1. F of x equals x cubed minus 1. Now you know what it looks like because you know the parent graph's got a vertical shift of 1 down. So it's going to be 1 down from the origin, and it's going to look like this. But they want you to check it algebraically. So f of x is equal to f of negative x. So plug in a negative x wherever there is an x over here. And see what you get. So parentheses cubed minus 1, plug in a negative x. Well, what's negative x cubed?
Negative X.
It's going to be what?
Negative X cubed.
It's going to be negative x cubed. It's not going to come out to be positive x cubed. It's going to be negative x cubed. So, f of x is what? F of x is x cubed minus 1. Are these two equal? No, they are not equal. So therefore you have to go to the second test. The second test says f of negative x, which you've just figured out right there. Right here, negative x cubed minus 1. There's something wrong. Oh, it's just x cubed. Don't do the minus 1 part. That's why minus 1 is symmetrical. Don't do the minus 1 part. I'll explain in a minute. Okay, so that's not equal. So now let's do this part. F of negative 1, f of negative x is negative x cubed, so that's right here, is equal to negative f of x. So what happens when you put a negative in front of the x cubed function? What do you get? Negative x cubed. Are these two equal?
Yeah.
So they're equal, so therefore you know it's odd, and you know it's symmetrical around the origin. Okay?
How did you know that it's around the origin?
Because it's odd. Because it comes out these two are equal. See, these are algebraic. Now you can tell it on the graph, but what they're asking you to do is to run these two tests to see algebraically if it's around the origin or around the y-axis.
So the two tests are, because I'm mixed up on the other one probably though, because it had f of negative x minus x. What are the two tests just that there?
The two are, check the first one, f of x is equal to f of negative x. If these come out to be true, then it's even. The second test is f of negative x, which you just found right here. Compare it to negative f of x. If this is true, then it's odd. If neither one of them are true, then it's what? None of the above. Somebody turn that's for easy. It's NEI, isn't it?
Yeah.
That's what I thought. Neither, N-E-I-T-H-E-R. So let's find one in the, I'd like to find one in the homework that actually has finding it algebraically, not with any graphs or anything. So that's what I'm going to try to find next. So, do they have any that you actually find? There we go. Just ignore this part and just do the function. Just do whether it's odd or even. Have a good day. Yep, Wednesday, bright and early. So my function is x to the fourth, f of x is equal to x to the fourth minus 8x squared plus 8. And I'm going to compare it to f of negative I'm going to compare it to f of what? Negative x. So that means I'm going to plug in a negative x wherever there's a what? So f of x doesn't change, it's still here. X to the fourth minus 8x squared plus 8 is equal to x to the fourth minus 8x squared plus 8. So what can you tell me about this function? I'm sorry, what?
That means it's around the y-axis.
Which is even. So you take your handy dandy cursor and you put even because f of negative x is equal to f of x. All right, you try that one. So our function is 8x cubed minus 9x. So I'm going to go over here and I'm going to say 8 parentheses cubed minus 9 times parentheses. And I'm going to plug in what here? Negative x, and I'm going to plug in a negative x here. So listen, nothing changes over here. I'm just using it to test against. What is negative x cubed? Negative x cubed, so that's negative 8x cubed plus what? Are these equal? No. So then you're going to have to check to see if it's odd. It's not even, so that doesn't work. So you got to do the next one. Now the next one, we take this guy and put it on the left. So negative 8x cubed plus 9x is equal to negative parentheses and then 8x cubed minus 9x. Now what happens when you distribute that negative in front of f of x? What happens? You get what? You get negative x, 8x cubed plus what? Are these equal? Yes. So therefore, this function is what? Odd. It's very important that you learn these.
Yeah, that makes more sense.
Yeah, it makes more sense because you have the negative x in front. The negative is in front. And that when I was a student, I grabbed onto that negative f of x more than I grabbed onto that because to me the negative x kind of confused me.
Yeah.
But it'll come, just do the problems and it'll come. If you raise a negative, and let me just go back and remind you, if you raise a -3 to a exponent of 2, you're going to get a what? Positive number. If you move, if you, let me put parentheses here. If you do a, it's supposed to be one here, somewhere. If you put a -3 to a odd exponent, you get what? You get a negative. All right. So that's where that comes in. That's that negative x. So if I plug in a negative x into a cubic function, what am I going to come out with? Positive x cubed or negative x cubed? Negative blank to the third. What do I come out with? Negative x to the third, negative. Negative star to the third, negative. Anything to the third power is going to give you a negative. Anything to an odd power is going to give you a negative. Most of your odd functions are going to be around the origin. Most of them. Okay? So let's look at a nerd. Next one will probably be neither or neither. I don't know. Try this one. Oh, me. I'm hungry. I'm just wrong. All right, what happens when you plug in a negative x or a negative number to a fourth power? Positive, so you're going to get x to the fourth. What happens when you plug in a negative x to a square? So you're going to get 5x squared. So what can you tell me about this function?
It is even.
Even. I'm trying to find one that's not.
Well, how do you show that equation of your answer?
What equation?
What you just put, because you had to show the f of x.
I don't know what you're saying. What I had to show.
You had to tell it even, and then you had to select one.
Yeah, this is right there. Because I plugged in negative x and it came out to be the same as f of x, the original function. You have to compare the two functions, the original function and the function you get. If they're equal on the first test, then it's even. If it's not equal, then you go to the second test.
Okay. Because I've got the odd or the even formula being f of x equals f times negative x. Yeah.
Yeah, that's right. It's got on different sides. I don't mean anything.
Okay, that's
That's
what's
Jody
on
and
the
Susie. Put
Okay.
Jody on one side of the
That's what's
seesaw. Doesn't matter.
Gotcha.
Okay.
Got
Now-
a mental block from there.
Well, you'd be surprised how many people think that's a problem.
Yeah.
It's not a problem, but all right. This one you can tell you don't even have to plug it in. Why? Because you know what the absolute value looks like. What does the absolute value look like?
It's gonna be,
Odd or even?
it's gonna be even.
Even. You know that because of what it looks like. X cubed, I would say it's going to be, but I don't know. We did that one. That one I would graph. I would graph that one, just look at it. Because there's no sense in doing that. I mean, you're going to have a negative here. You're going to have a positive here. So that's going to be negative 0.3x to the fifth, positive 3x minus x. And then you have to compare. It's not going to be even, I can tell you that. So you might want to look at it. Let's graph it and see. Because I would tell you if that showed up on the test, do it in a calculator. Because there's no sense in doing all that. That's just tedious, busy work. Y is equal to 0.3 x to the fifth power minus 3. Is that a point? That's 3, right? 3x to the third power plus x. Is that it? What's it around? It's not the parking lot, y'all. What's it around? The origin. So it's around the origin, wherever, right here. So you got a better feel on that now? Most of the time your odd function is going to be around the origin. That's why you just need to graph it, especially the more difficult they get. Just graph it on the calculator and you can tell. Okay? Now let's talk about, again, increasing and decreasing, because that problem that we just did, that problem we did in homework, that sucks. Okay? That's not a good problem to talk about. Let me go back to the beginning of the homework and see. Where's the beginning of the homework? There's 21 questions. Why is it only showing? Is that it? Okay, here's a good function. Just look at the function. I don't care what the question's asking. All right. Now I want you to write the domain, range, and write down where the function is increasing and decreasing. So, my plane just got a little bit more streamlined. Doesn't feel like writing it. So the domain is going to be negative infinity to what? Positive infinity. Range, negative infinity, positive infinity. And take our handy dandy airplane. And what's the airplane doing?
Okay.
It's increasing where? From negative infinity to what? Increasing from negative infinity to positive infinity. Yeah, pretty much. Yeah. I'd say it's UFO. It's heading to Roswell. So it's from negative infinity. It's coming, it's coming, it's coming, and it's coming, it's coming, it's increasing, and it's increasing, and this is increasing. Kind of constant right here. You could say it's constant in this area, but for instructional purposes, for the x values, it's increasing. The y values are increasing from negative infinity to positive infinity. Increasing from, be careful, increasing from, no, 0 to what? Infinity. Remember, increasing and decreasing values in terms of x. Domain is in terms of x. The only thing in terms of y is what? The range, Hubert. That's right, class. Thank you for the interaction. So, range is from 3 to what? Infinity. It's the only time you use the range. Only time. I mean the y. Only time. The y values are increasing from 0 to what? I don't know what the question's asking, but I do want you to be able to understand increasing and decreasing more than anything else. Domain, range, increasing and decreasing. Trying to get to the next problem. Trying to find, okay, here we go. What's going on with this problem? Well, from negative infinity to 5, what's it doing? Increasing. And from negative 5 to infinity, what's it doing? It's increasing. All right, so it's increasing here, and then it picks up here. It's not inclusive at negative 5, so it'd be parentheses negative 5. So increasing from negative infinity to negative 5, parenthesis, increasing, parenthesis, negative 5 to infinity, parenthesis. The domain is all real numbers except x cannot equal what? Negative 5. Your range is from negative infinity to 0, non-inclusive of 0 because it doesn't touch, and from 0 to infinity with parentheses because it doesn't touch 0. And that red line is called a vertical asymptote. So you could put, I don't know, it's not continuous because is it the nice piece of concrete that keeps going? No. You hit like a brick wall right here. So it's not continuous. It should be not continuous. I don't know what that means. I don't know what they've made up here. Probably the right answer, but it looks like to me it's that. Yep, I knew they'd do that. They want you to put in all that stuff. I'm not going to do all that. All right, but it's not continuous. Okay, here we go. Increasing. This is a test question. We call them the increasing and decreasing. This is so annoying. Okay, so what is my plane doing from negative infinity to 3 or whatever for 4? What's it doing? Increasing. And then from 4 to 6, what's it doing? And then from 6 to infinity. That's how you do it. Just remember your plane. And remember, there's 2 things you remember about increasing and decreasing. Plane, the plane, and You only deal with the x values. Don't even look at the y values. Just what is this guy doing?
I guess that still throws me off because your x value is increasing.
Yes.
So how do you know?
That's what you're telling. You're saying, no. You read from left to right. That's only because you read from left to right. If you were from Saudi Arabia, it wouldn't be decreasing. It would be decreasing. It wouldn't be increasing. All right? It would be going the other way. I'm just saying that. I'm just saying you'd be reading right to left.
Yeah.
That's just a coincidence, okay? I don't want to just, you're looking, what's happening to y as you move along the x-axis?
Okay.
Let's say it that way. What's happening to y as you move along the x-axis? What's happening to y as you move along the x-axis? And what's happening to y as you move along the x-axis? That's how you need to say it. Okay? That's a good test question right there. That's not a good test question. It's a terrible question. And this is standard view calculator. What does this say? Interval and so on. What do they want to know? Because it's what? Oh, increasing, decreasing. So that's negative x cubed. So it looks like this. Our regular x cubed looks like that. So what does negative x cubed look like? Be on the other side, and so you can do this without even looking at a graph. You just sketch it in your head. What is the function doing from left to right? Decreasing. And you know that because you know your parent graphs. So you didn't have to do it because you did it in your head. That's why those parent graphs are so important. If you want to suck at algebra, just don't learn the parent graphs, and you will suck at algebra. All right, what about this one? What is this one doing? Well, remember your parent graphs. First of all, the absolute value of x looks like this. So what does the negative absolute value of x look like? It's going this way. Now, the 5 is not with the x. It's not inside the absolute value mark. So what shift is that? The vertical shift. So looks like it's one of these two. Remember, if you want the horizontal shift, the horizontal has to be in touch with the x. And these absolute value marks or an exponent cuts that 5 off from the x. So the 5 is a vertical shift. And it's probably going to be this guy. Why isn't it this? This is horizontal shift, this is horizontal shift. This is a negative. So chances are it's this one. And you feel good about yourself. That's a good test question because it's real simple. How about this one? Negative x cubed plus 1. Decreasing. Well, there, I did that without even drawing it. Wow, how did I do that? Because I know my parent graphs. All right, what is this? What does this say? Determine whether this is symmetric with respect to. Determine visually whether the graph is symmetric. Okay, symmetric around the y-axis, x-axis, or origin. It's around the x-axis. That's what it should be. Usually they don't ask that question very much. I guess I just wanted to confuse you. Okay, that's the sine curve, as I was telling you, and that's what this is. You might want to write this down, number 41, SIN curve. This is the SIN curve. I told you before class that in calculus you study the sine and the cosine curve, and what is the sine curve? It's odd because it's reflected around the what? The origin here. That's right, class. So, well, there's two things you got to have when you talk. One is enunciation, and the other one is volume. Or if you don't have those two things, then you sound like
origin.
So that makes me feel good. Thank you. What?
So the sine curve is odd.
And the cosine is even. Have you ever listened to voicemails before? Sound like somebody that's retarded or something.
Obviously, we want some.
I'm serious. I have listened to my voicemail in my office. How am I? Y'all think I'm kidding? I got 3 teachers to listen to this person on voicemail, and they could not understand a word he said. They couldn't.
Hey, I deal with the public every day and listen to voicemails. 90% of people are terrible. And they say their phone number like you know it.
Yeah.
It's like,
You have to rewind it like 7 times.
It's like, say the number, 224, pause, wait a second, say the rest.
I just love it when they do it. So it's slobbering at the mouth or something.
Yeah, we've had some of them that we could not figure out what their name or their phone number is.
Yeah.
I mean, it's like, Billy.
It's awful.
Like, I left you a message. It's like, no, it sounded like you were slobbering on the phone.
Yeah, it sounds like that. I should have kept it so I could play it in class. I should have done that. Okay, so that's that. So now you know how to do the parent graphs. You know how to do the odd or even. You know how to do the domain and range. You know how to do increasing and decreasing. Y'all know I could just give y'all a test tomorrow, because I'm not going over piecewise functions. I don't go over piecewise functions till later. But I don't. In college algebra, I don't give y'all a test until Unit 2, and I give you 2 tests. And there's a reason for that. Next week, we're going to do nothing but complete the square all week. You're going to do about 15 or 20 problems in class, and you're going to do about 100 problems online. All right? Complete the square is the best way to do a problem, period. Okay? But I'm not going to do that to you today. What I want you to finish up, you should be finishing up chapter 2. Do not do 2.6. Go to the outline. What does the outline say? There it is. Take that one out. Okay? You are responsible for the Unit 1 test, which will be when I do the Unit 2 test. I'll give them together, and you'll have a week and a half to take both of them. Then some of y'all are going, I cannot believe you're giving us 2 unit tests at one time. Just let me show you one thing. Let me show you one thing, and you'll see why. I'm very aggravated. I'm fixing to get very aggravated. In Unit 2, this is what we're doing. X squared plus 4x plus 4 is equal to 0. Quadratic equation, right? Everybody with me? What does this look like? No, what does this look like? This looks like f of x is equal to 1 times x plus 2 quantity squared minus 0. What does that look like? A is 1. What does A tell you?
This
is a quadratic. What does that mean? It's a parabola, parent graph. Okay, what does A tell you? 1, that's normal. That's the basic model. What does the 2 tell you? Left 2 places. What does the 0 tell you? Vertical shift. Remember all the stuff we went over last time? That's what we're doing. Actually, they should do this first, and they should teach Unit 1 second, but they don't. So that's what we're doing. So when you're doing the Unit 2 test, you're actually reinforcing Unit 1, which is your orientation, your horizontal shift, and your what? Vertical shift. So when you take those 2 tests, it's going to be like taking one test. It'll all be the same stuff. All right. let me get the roll. I think everybody's here, but I gotta take the roll. Let me stop that recording so it'll be processing.